Today we are going to see integrator. Aim of the experiment is to design, build and test an integrator using op-amp ic741 for given values of FA and FB. Also to plot the frequency response of op-amp integrator. The equipments or components required for performing this experiment are op-amp ic741, this is 8-pin IC, resistors of value 1 kilo ohm and 10 kilo ohm, 2 resistors of value 1 kilo ohm and 1 resistor of value 10 kilo ohm. Ceramic capacitor of value 0.1 microfarad. Then dual power supply for given positive and negative supply of plus 12 volt and minus 12 volt. Function generator for giving input square wave of 1 kilohertz and 1 volt peak to peak. CRO, that is cathode ray oscilloscope, for observing and measuring output of integrator. Then the patch cords, CRO probes and connecting wires. Let us see the circuit diagram of integrator using op-amp IC741. This is IC741 with pin 2 as inverting input, pin 3 is non-inverting input, pin 4 is negative supply, that is minus VEE, which is minus 12 volt, pin 7 is positive supply, which is plus VCC and it is plus 12 volt, and pin 6 is output pin. This is the complete circuit diagram. Let us start the connection of circuit diagram. Connect resistor R1 of 1 kilo ohm between pin number 2 and second pin is for input. Connect resistor RF of 10 kilo ohm between pin 2 and pin 6. Now connect capacitor of 0.1 microfarad between pin 2 and 6. Connect 1 kilo ohm resistor between pin 3 and ground. This we are going to consider as ground. One volt peak to peak, 1 kilohertz square wave from function generator as shown here. Now switch off the function generator. Set power supply of plus 12 and minus 12 volt. Short the positive and negative terminal. Connect the common to ground. Now this is the ground. Connect positive of power supply to pin number 7. This is pin 7. Connect negative of power supply to pin number 4. This is pin number 4. Give input from function generator to pin number 2 where we have connected a resistor. This is the input. Same input can be observed on CRO using this probe. Connect output to pin number 6 and connect it to CRO. And connect all grounds together. Now switch on the power supply, function generator and CRO. Use CRO in dual mode so that you can observe both input and output. This is the input square wave and this is the output of integrator, which is nothing but a triangular wave. Now let us take the observations. The values of resistors and capacitors for this integrator are obtained from the design of integrator. We have designed the integrator for FA, which is equal to 160 Hz and FB, which is equal to 1.6 kHz. So we are using the formula of FA, which is 1 upon 2 pi RFCF and FB is 1 upon 2 pi R1CF. So we are going to assume a value of CF, which is equal to 0.1 microfarad, and from the formula of FA and FB, you can calculate the values of R1 and RF. R1 comes out to be 1 kilo ohm and RF comes out to be 10 kilo ohms. Similarly, you can find out the value of ROM, which is parallel combination of R1 and RF, which is approximately equal to R1. So ROM is also 1 kilo ohm. Now let us see the observation table, in which we have first column, which is frequency, second column output voltage, then third column is gain, which is the ratio of V0 by Vin, and the last column is gain you are calculating in dB, which is 20 log of V0 by Vin to the base 10. Now here we have kept the input fixed, which is equal to 1 volt peak to peak. Now you go on changing the frequency from 50 Hz till 2.5 kHz in different steps as shown in the observation table. It is seen that the gain almost remains constant till the frequency FA, which is 160 Hz theoretically, but practically it may be slightly less than or more than 160 Hz, and after FA it starts decreasing at a rate of 20 dB per decade. That is, for every 10 times increase in the frequency, your gain is decreasing by 20 dB. The gain decreases till FB, and at FB, which is 1.6 kHz theoretically, and practically it may be again above or below 1.6 kHz. At FB, the frequency again becomes equal to 0 dB. This frequency is called as the 0 dB frequency or unity gain frequency. Now plot the graph of frequency versus gain in decibels on a semi-log paper. With frequency, you have to take on x-axis and gain should be on the y-axis. The scale of frequency is 10, it should be multiple of 10. That is, if you are taking 1 Hz, the second scale should be 10, third should be 100, then 1 kHz and so on. Because this is a logarithmic scale. Now show FA and FB on the graph. Also show gain when frequency is 0 Hz, that is without applying input. This is the maximum gain of integrator. From graph, we can see that between 0 to FA, the gain is constant, where op-amp behaves as an amplifier. Whereas between FA and FB, gain is decreasing, and in this region, op-amp behaves as an integrator. Bandwidth between 0 to FA is called op-amp bandwidth, and 0 to FB is nothing but unity gain bandwidth. So this is how we are going to perform experiment of integrator using op-amp 741, and we are going to plot the frequency response for integrator. Now go on increasing frequency and observe that the output will be constant till 150 Hz or 160 Hz, and it goes on decreasing as you go on increasing frequency. You can see that as frequency is increasing, gain is decreasing, and at one frequency the input and output will become equal.